Hi, it's Robin. Got something here. It's Jim Butterfield's diary. Well, more specifically, the Commodore Reference Diary by Jim Butterfield for 1986. Comes in this jacket. Actually, I'll probably remove that since it's so shiny. The 1986 computer diary. I think this was specifically for the UK market, and that's probably why the word diary is used here. Here in North America, I think we generally think of a diary as like a personal log that can contain quite personal information. And that'd be funny if this was Jim Butterfield's his personal diary full of salacious secrets or whatever. But I believe what's called a diary in the UK, here in North America, we would often call a day planner. That is kind of like a calendar of what you would do. So that's what this is. In 1986, there's an entry for each day, and you might make your your business plans or whatever in here. Well, if we open it up here, the Commodore Reference Diary 1986, Jim Butterfield. And that got me wondering, is this actually Jim Butterfield's signature here? So I spent quite a while searching online trying to find Jim Butterfield's signature to see if it looks the same. And I wasn't able to find anything. Then it occurred to me I actually have Jim Butterfield's signature. That got me digging around here. Just gotta find something here. Now, where's that box? Here, okay. Oh. So this reminded me of this box I got from Jim Butterfield years ago. And in here is this handwritten note. And actually, some of you are probably wishing that this is what the video was about. Well, we'll take a quick look at it, but this is by CMD Canadian Micro Distributors. Not the CMD of the USA that made like the super CPU, the MUPET, made in Canada, out and in. Okay, and so there's a bunch of these devices, and this is essentially like a networking system for the Commodore PET. It's got these cables. It's got this big master unit that I'm a bit scared to pull out of here, but I better, It's filthy. Yeah, it was like the, early to mid 2000s that I got this from Jim. Oh boy. There's this box. This is like MUPET 2. There we go, Canadian distributors. Oh, the ready lights popped out there, so this has seen some damage. And on the back, it's got these edge connectors. I'll probably take another picture of this just so you can see it. It needs a good clean. I think that's like the control box. I have no idea if it works. Oh, okay, anyway. Yeah, there's the power cord for it. So just as valuable to me as the actual hardware is this note that Jim Butterfield himself wrote for me to explain it. The MUPET connected several PET CBM computers to a single floppy drive. It was hardware only, no drivers were needed. Popular in schools where multiple disk drives were too costly for the budget. Manufactured near Toronto by BMB CompuScience, whose manufacturing arm was amazingly called CMD, Canadian Micro Distributors. So again, not the creative micro designs that was making the super CPU and all the other hardware that was so well known in this era when Jim was writing this. So he's saying amazingly because it was quite a coincidence that there was this other CMD, and both companies are long gone. Again, meaning the BMB, CompuScience, and the Canadian Micro Distributors. So Jim wrote this, and then he signed it for me, joking and humble as always, lies, Jim Butterfield. Okay, so so I know that this is Jim Butterfield's signature because I saw him sign it right in front of me, and it's pretty clear that, yes, this is very likely the same signature. The J's a little different, but a lot of similarities. And the fact that the B doesn't actually have a double B here, we are doing some handwriting analysis, but it seems pretty clear to me that this is the same signature. This would be at least 15 years later. And of course, I'd really like to do a video about the MUPET sometime. Yeah, I don't know if it works, and it's just actually going to require a lot of space to set up multiple PETs with the disk drive and so on. But anyway, that really is something I should do, of course. Just it hasn't happened yet. Okay, so back to the computer diary. All that to establish that, yes, indeed, Jim signed this himself. I just find this such a curiosity. So, of course, it was in 1985 that they would have been preparing for the 1986 calendar. And it was this Pitman Publishing in London. Copyright 85 Jim Butterfield and Pitman Publishing. Printed in Great Britain by Charles Letts and Company. Useful addresses. The ICPUG, the Independent Commodore Product user group, and that's apparently the largest group in the UK, which is a network of regional groups. And, of course, dear to Jim's heart, the Toronto PET users group here in Canada. TPUG is one of the world's largest Commodore user groups. Now, I'd argue it was certainly the largest, but I guess they had to be careful about that. And acknowledgements. Some of the reference material in this diary has been previously published in The Transactor, and we've looked at that and reprinted as part of the complete Commodore Inner Space Anthology. The author wishes to thank Carl Hilden, my friend, the managing editor of The Transactor, for his help in coordinating republication. Okay, so it has a hexadecimal conversion chart. And here we go. The Commodore range of computers. So I guess this is all the sort of stuff that if you need the Commodore Reference Diary, you have all this information in your pocket back in those days before cell phones. And Jim writes up a nice description about each of the computers. So the PET CBM was certainly long in the tooth by 85, 86, but that's where it all started for him. Was the Super PET really for sale? Maybe in early 1985 it still was. CBM 8096, which was an 8032 with an extra 64K. Pretty interesting to see the C16 and the VIC-20 still listed there. When the Commodore 64 was so much more powerful and inexpensive and well established. Okay, the Commodore 64, versatile large capacity computer. The 700 series, built-in keyboard, adjustable screen built into some models, screen 80 columns by 25 rows, RAM memory varying from 128K to 256K, possibly more in the future. And there's the Plus 4. Actually quite a write-up. Sounds very impressive the way Jim describes it. And the Commodore 128 would have been brand new right then. And finally, the Commodore PC 10 and 20. Two models, PC 1020. The PC 10 has two 5-inch floppy disk drives of 360K each. And the PC 20 having one floppy disk drive of 360K and one 10 megabyte Winchester drive, both intended for the business market. Totally IBM PC compatible. Then after the description of the computers, all the different peripherals available. 2 basic styles of 5¼ inch floppy disk drives are available, 35 track and 77 track. All disks are intelligent. There is no need to load a DOS system into the computer's memory. And going through here, describing, so this is a real slice of history. I guess this is a whole bunch of knowledge that Jim sort of assembled together over many years. And then when approached about this computer reference diary, it all came together here in this summary. 1571 was just brand new then. Printers, modems, others. Important keys. Cursor positioning and screen clear. Reverse on, reverse off. Colors. Pressing the appropriate key combination will cause the following text to be typed in the selected color. And there, I fully approve, Jim. The stop key. This causes a basic program listing or disk load to stop. The computer will often report break. Run, shifted stop, will cause the computer to seek to load a program from tape or disk and run it. I'm on team stop, not team run stop. An article about basic structure, basic variables, distinguishes between constants, numbers, and strings, which do not change in variables. I like how we can't help but get a little optimization tip in here. If a constant is used often in a program, it may be useful to define it within a variable, even though it will not change. Variables are usually more compact and faster than constants. Okay. Special variables, st, ti, and ti string. We've looked at those in other episodes. And the extra disk commands on the PET 4.0, 700 series, the +4 and C128. Basic commands. That was just a quick summary of basic. Disk commands. And it's interesting how he's grouped it together. Simple, as in your regular basic 2.0, how to load a directory, for example. Wedge, if you have some sort of command wedge installed, as supplied by Commodore, or just like most fast load cartridges on the C64 include. And then advance, meaning some of the higher basics would use the directory or catalog command, for example. So he's got equivalents of how to do all these different disk operations in 3 different ways. The bump killer. To avoid the potentially damaging bumps sometimes performed by the 1541 drive, especially when loading protected software, proceed the load with, and it sends a certain memory command. This may interfere with the loading of some protected software. Pattern matching. Yeah, so the question mark to match any single character in that position. A star matches all characters from that position. And the equals allows specific file types to be examined in directory. Simple techniques and handy locations. On the early PETs, you had to poke to switch to text mode, meaning upper lowercase mode, and later you could just print character string 14. Disabling the run stop key, restore. Hey Jim, why aren't you calling it the stop key now? It's interesting, the cold start. All Commodore computers can be reset to power up state with this combination of sys. So that's something I hadn't realized, that there is a reset vector at a constant location in all 8-bit Commodores. The high byte is in this location. You multiply it by 256 and then add the low byte. This is getting pretty obscure. You can do a rem shift L and that will block the listing. Omitting line numbers. Okay, and just to try out a few of these simple techniques and handy locations. So yeah, if you print character string 14, it'll switch most Commodore computers to lowercase. The early PETs, you had to poke them though. And then to go back the other way, print character string 142 will switch you back up to uppercase or graphics mode, as it's known, because then more of the graphics are available when you shift. You can also just hit Commodore and Shift to switch between them. And if you want to switch out that functionality so that you can't switch while program's running, then print character string 8 on the Commodore 64, and then that feature is disabled. And character string 9 re-enables it. Okay, if we have a little program here, print hello, you can run it. And if you wanted to disable run, stop, and restore, normally you can hit stop restore, and it does a warm reset on the computer. We can disable that according to this with poke 808, 234. That changes the vector that the stop key goes through. And now stop restore no longer works. But it has a side effect that if we list, it breaks listing. That's curious. This is interesting about that sys for reset. Instead of actually doing the sys, let's just peek those locations. Peek 65532 and add it to peek 65533 times 256, and this should return 64738. There it is. So if you want to know the address to do a reset on the computer, printing these two locations, this one multiplied by 256, because it's the high byte, it'll give you this address right here. And then if you call it with a sys, 64738, it'll reset the computer. That number, I don't know for sure, that's different on every single 8-bit model, but at least most of them will have a different address. There might be some that share the same number. There we go, another reset. An obstructing list. So yeah, if we have a program that's like hello and 20 there, and if we run it, hello there, and of course you can just list that program. But if you want to obstruct it, add, for example, line 15, rem, and then shift L, and press return. Now, if we try to list, instead of listing, you will get a syntax error. And this is something I should do a full episode about sometime, but what it's essentially doing is injecting an illegal token into the remark, and when the program is listing, the interpreter gets confused by this shifted character and causes the syntax error. If we just delete that line 15 and then list again, then it lists again properly. And omitting line numbers, let's try this. Poke 2235. Now let's try listing. It gets rid of the line numbers. So our program's still there. Let's see if it still runs. Hello there, yep. But if we try to list it, oh there, our line numbers are back. Something about running it must restore that value. Let's try again. We'll poke that and list. That's kind of cool. Okay, so that's it for those simple techniques and handy locations. And here's these really interesting, the memory architectures for the PET CBM. This is so tiny, I'm having trouble reading these, but I really do like these diagrams. There's the PET CBM, the VIC-20, and you see how both of these diagrams, how they are all flat. They're like two-dimensional. And the Commodore 64, see how it's multi-layered here. You have your actual RAM, but then you have like the basic ROM on top, the kernel ROM, and they have things like I/O, So the Commodore 64, you can see how much more advanced its memory architecture was. Well, that's nothing compared to here, the 700 series has all these different banks, and it keeps like your basic program in one, arrays in another one, variables, strings. Kind of ridiculous, but also interesting. And then bank 15s on the top. And this kind of inspired the Commodore 128, I think. And here's the +4. Nice and simple in a way. Those are really cool little diagrams. Oh, and here's the Commodore 128, which dedicates one RAM bank to your basic program and the other 64K to your variables and arrays. Useful memory locations. So this is basic for, in 1985 or 86, this may be a bit confusing to newcomers who had like a Commodore 64 or 128. Basic 4 is for PET machines, or CBM PET machines. So it's like a little memory map. These are the I/O chips here. CRT controller. Here we go, the VIC-20, Commodore 64, and 128 in C64 mode memory map. Again, we've discussed before, but the VIC-20 and Commodore 64 have a lot in common for memory maps and so on. And then what's unique about the VIC-20 and Commodore 64, Commodore 128. So this is, what a handy little book, eh? Have all this information with you all the time. For a certain kind of computer nerd, this must have been the best thing. Oh, and there's the 6567 video chip. The extra registers, the Commodore 128 extends the VIC for the extra keyboard and the fast clock speed. CIA memory map, SID, the +4 memory map, preliminary. And I guess he never did revisit that. The +4 was such a flop in the North American market, he probably didn't bother with it more after. I don't think I've ever seen a TED chip break down like that. Of course, part of the idea with the TED was that it was cheap, so they crammed so much function, like the input-output functions, the video functions, the sound, all in that one chip to make it cheap. And then they sold it for more than a Commodore 64. The 700 series memory map. 6525 chip. I guess that's the CIA equivalent in the 700 series computers. And of course it has a SID. Oh, it does have a 6526 as well. And yeah, some of the machines have a SID in them. Oh yeah, here's the super chart. That is so cool. In the Complete Inner Space Anthology, I use that all the time. And what's so cool about it is just how it shows all the different interpretations. Like, for example, a 32 decimal is 20 hex, and that gets interpreted as a space in both PETSCII and screen codes, and in BASIC, in this case. In machine language, it's a JSR opcode. But it's just such a handy little thing here. Here's all the values. Useful programs. Detecting key hold. The get command detects a key and extracts it from the keyboard buffer, but if the key is held down, get won't see it again. Hey, there's that one-line PET emulator that I did a video about before. Outputting in columns, numbers in columns. Calendar dates. Some neat little type-in programs. File inspection. Rounding. Sound. How to make sound on the C64 and also on the VIC-20. And interestingly here, the values given here are for European, that is PAL machines. Because of different clock frequencies, they must be modified for North American machines. So yeah, because of the slightly different clock speed of the computers, that affects the pitch that the sound devices make. Oh yeah, actually the calculation's given right there. Machine language processor programming model. I find these different approaches to categorizing the 6502 opcode set really interesting. Shows the actual opcode name and then the different addressing modes or variations, what hex value it is. More addressing modes, kernel calls, and a glossary. These glossaries are often just kind of pulled together from wherever, that they're not very Commodore specific. Personal notes, notable dates. Here, finally, normal people stuff in your diary. National holidays. If you're in Belgium, Canada, Denmark, France, Germany, Greece, Italy, Netherlands, Spain, and USA. And the calendars for 85, 86, and 87, the years surrounding it. Okay, now this is pretty amusing. Okay, now the previous owner of this book decided that, I know I'm being flippant here, decided that instead of having a life and scheduling things in this diary, they would write their collection of pokes in here. So 1 poke for every day of the week. Resetting, disabling the keyboard, and they've talked before, especially in that Commodore 128 Black Book episode, about how there was a whole bunch of Commodore users who were fascinated with pokes. To them, pokes was what computing was all about, that there were all these secrets hidden inside that computer, and if you just knew the right poke, the computer would do what you want. And I think that's what drove people to these. Like, I guess they're just like fun to collect and to ponder over. And it wasn't as difficult as, writing a whole program or anything. You could just poke and the computer would do something different. Key repeats. Now, I did briefly wonder if this could have been Jim Butterfield himself have written this, but I don't think so. And actually, I have all I need to show that now. Since I happen to have this sample of Jim's printing, as well as his signature, I think the easiest way is just to see the letter D very consistently. Here we're doing handwriting analysis again. A D for him is very much a curve with a line connecting it. There's several examples here. He's very consistent. It's like a bow shape with a line. And if we look at this guy's, there's lots of D's in here. And it's very much a different shape, like a loop. The D is very much a stick, and then a round thing coming off of it. There's another one here. Disables and so on. So I'm basically certain that this is not Jim Butterfield's printing in here. This is somebody else who owned this book. So just to look through here, disables stop restore, enables load, save gives cold start. Wow. Turns off screen, computer runs faster, turns on screen, switches graphics mode, border color, background color, re-enable fast load, obviously if you have a fast load cartridge, background color, undo, drive crash fix, checkerboard. Okay, and just to try a few of these pokes here, that's 64738 again. Input without question mark. Well, normally if you do a program here like input A, and then you print that, if you run the program, there is a question mark prompt, and just in this case, we're just printing whatever was inputted. Sometimes that question mark's a bit annoying. So here, let's try this. Add line 5, poke 19, 65. List that. And now let's try running it. Okay, and now it's waiting for our input, but it doesn't display the question mark. And it also didn't print a new line after the return. It's interesting. Here's one. Mindless printing machine. I do not know what this one does. Poke 120, 0. Okay. Hello there. So it seems to have disabled the processing. When you press return, nothing happens because we're not, normally you would get a syntax error. Here, I'll hit stop restore. Normally, it's still broken. 64738. So even stop restore doesn't fix that one. So I'm going to have to power cycle to fix that one. Because normally if you type hello, you get a syntax error because it's not an instruction the computer recognizes. Okay, all keys repeat. Normally only certain keys repeat, like the space bar, the cursor keys. But if you press, A, S, they do not automatically repeat. And I got this one memorized, poke 650, 128. And now all the keys will automatically repeat. That could be handy during data entry sometimes. Now if we have our little program there again, print hello there. And how about this one? List only line numbers. Poke 774, 0. And now let's what happens if we list. Oh, yeah. It only shows the line numbers. And if we run, it still runs. I don't think I've seen that one before. If we want to disable run, poke 808, 127. Now we'll run. Oh, it immediately breaks. But we can still list our program. Well, still with broken line numbers. We're really breaking basic today. Save gives cold start. Okay, I have to try that one. Poke 818, 226. Poke 819. A little bit of shorthand there. 252. Oh, can't even enter things in direct mode. It automatically stops. Okay, so stop restore. Does that work? Okay, let's try that again. Poke 818, 226. Poke 819, 252. Okay, now let's try it. Can we still list? Yep, well, it's still broken. Save. Hello. And what happens? The computer reset when we tried to save. So that must be just redirecting the save vector to just do a reset. That's pretty funny. Change cursor speed. Let's try this. Poke 56325, comma 128. Okay, watch the cursor blinking. There, now it's way slower. $250. Very slow. Oh, and even the cursor movements are slower. So I think this is actually decreasing the system interrupt speed. That looks pretty normal. Let's try making it something very small. That is fun. Whoops. Oh, I did the wrong poke. Out of habit, I poked 53265, and that actually disables the screen. Let's try 56325. I was kind of dyslexic there. Comma 1. That's enough of that. Pretty fun, though. And then some blank pages. And then starting here on April 28th, the various colors and also character string numbers for them. They're just kind of scattered all over in Petsky. Actually, this is the whole character set. Kind of funny that that all got put in there, but since that was already available in that super chart. And then lots more blank pages. And one last section here. 1987 Forward Planner. The 64 Uncrasher. I dealt with that in that kernel episode. That is that old kernel bug that could totally freeze up your machine, but you can use your tape drive to fix it. Add comments to directory. So this is somebody's personal collection of Commodore secrets collected over the years. Oh yeah, and here we go. Principal Rail Service in the UK. And there's even the London Underground, in case there's any doubt that this was meant for an English audience. That back in its sleeve. Okay, so that's a look at the strange little, I'm going to call it an artifact, Jim Butterfield's Commodore Reference Diary for 1986. Funny little thing, but it might have been somebody's prized possession back then, or they might have truly looked at it each day. And I like how it was used to just collect all Commodore information by whoever it was that owned this. Okay, thanks very much to my patrons for their support. Thank you for watching, and we'll talk to you next time.